We're going to go ahead and finish chapter 3.2 notes with introduction to the empirical rule and then the example at the end on the last page of the notes. The empirical rule sounds important, and it is important. The empirical rule. Okay, empirical rule is directly related to standard deviation. And so when we collect data, we're interested in what the mean, the median, or the mode is. We're now going to be interested in what the range is, or the standard deviation, or the variance. But most of the time, we're going to be very interested in the standard deviation because of the empirical rule. So we use the empirical rule when we collect data, and then when we graph the data, it has this shape. It looks like a histogram that we can draw over the shape like that. And when it looks like that, that is called bell shape. And another word we're going to be using, I'm going to introduce it, is called normal. We say the shape is normal. It's a normal curve, okay? When we say that because of this shape, it's bell shaped. And what that says, the empirical rule, is if we have the distribution, the shape of a curve or a histogram, we just don't have all the bars there, the shape of a histogram is bell shaped, then approximately, what we know, approximately 68% of all the data, right here, 34 and 34, here's the mean, the average right in the middle, there's your mean, approximately 64, there's your standard deviation, approximately 64 68% are within one standard deviation. You're going to want to memorize this for now, be able to draw it. You should practice that. That is approximately 68% of the data lie between what's called one standard deviation, one minus a standard deviation, and one plus not one, the mean plus one standard deviation. We also know that approximately 95% of the data lie within two standard deviations. So that notation becomes important. Looks a little weird there, but it becomes important. Lie between the mean and two standard deviations, and the mean plus two standard deviations. And so you can imagine all the people lined up, and most people are going to be near the mean, but then you have some people who are far away from the mean. How far? We measure by standard deviations. That's why it's an important value. And we learned that approximately 99.7% of the data will lie within three standard deviations, and it looks like this. The mean minus, if you're less than the mean, three standard deviations, or the mean plus three standard deviations. Okay, so that's the notes there. We're going to use that information to answer this question here. Let's say a doctor collects cholesterol level, and that's the data for 54 people. And so what's going to happen, what we need to do in this case, and I want you to draw this out, what you need to do is you're going to say, okay, let's make a histogram of this data. Okay, so we're going to make a histogram of this data. I have this data already put into the computer. So let's look at that real quick. The histogram is going to look 3.2, example 3. So here's the data of all the cholesterol levels of the 54 people. We want to make a quick histogram of the data. I have the data already in. There it is. Quick histogram. And when we do that, there's the histogram. It's nicely shaped there. We have this shape right here. We have this shape right here, and it looks, again, kind of like a normal curve. It goes from 30 to 90, and so there's the shape of that. Okay, and so we're going to draw, instead of drawing the histogram, what we end up drawing is a bell-shaped curve to represent. We end up drawing a bell-shaped curve to represent that data. We get lazy. We don't draw the bar, so we just draw a curve. It was nicely shaped. And so what do we, then we label this x-axis, right? And then on the y-axis is going to be frequency or relative frequency. And then what we do is we label this. And we're going to put right in the middle, we're going to put what the mean is. what the mean is. And so we need to calculate mean and standard deviation for this data. So you can do that from summary statistics as an example. And I need the mean and I need the standard deviation. We compute that. So you get 57.4 and then 11.8. 57.4 and 11.8. And so then what we end up here is the mean is 57.4. The mean is 57.4, and then the standard deviation was 11.8. That's what we have there. Okay, and so that's what you end up drawing there. And then how we label, we're going to label the x-axis by standard deviations. And so kind of relating it back to here, how it's labeled by standard deviations. The first standard deviation occurs like right when this curve turns, so we're going to label it kind of in those areas by standard deviation. That's how we measure. So what's the standard deviation? 11.8. So then this value here, let me get a different color. Then this value right here is going to be, when we label it, we're going to add 11.81 standard deviation. So that turns out to be 69.2 would go right here. And then this one would be add another 11, so that would be 80.2. This would be 81. And then coming back the other way, we would subtract 11, so that gives us 57.4. I need to do the math here. I don't have my calculator. 57.4 minus 11.8. 14, 6, carry the 6, 5, and so this turns out to be 45.6 right here, and then I subtract another 11. So that would be 34.6. 45.6 minus 11.8. So 16. That's my 8. I had to borrow 4, 3, and then 3. So this turns out to be 33.8. So we label it by standard deviations. And now we can answer these questions. Determine the percentage of adult patients. So remember, this graph represents all of these 54 people. What percentage of them will lie within 3 standard deviations of the mean according to the empirical rule? So this one's pretty easy to answer. We just go back to the rule. We learned that 99.7% of all data lie within 3 standard deviations. So I'm looking at that to answer that question. And so the answer to this one is, for part C, the answer is 90, for coming back here, 99.7%. 99.7% is the answer to C. Determine the percentage of all patients that have HDL levels between 34 and 69.1. So 34 is like right here, and 69.1 is like right here. And so if we look at that, that is pretty much, that distance is pretty much 2 standard deviations, right? From the mean. Oh, wait, no, let's do this again. 34.1. This is, let me erase that. From here to here is 2 standard deviations, right? From this distance to this distance, and then from here to here is 1 standard deviation. So you have these 2, and so we go back to the empirical rule, and so we're pretty much going from 2 standard deviations to here, and then in that other case from here to here. So we can add up those percents. It's going to be 34 plus 34 plus 13.5. And so that's the answer for D. It'll be 34% plus 34% plus 13.5%. So you add those up. That's 68, 78, 81.5%. About, again, it's an approximation because we don't have the exact values there, but it's going to be 81.5%, and that's the answer. Part E, I'm going to skip for now. You just actually have to count how many people fall between 34 and 69.1.